Okay, so this is the video. I'm gonna start with doing this first problem. This problem is exactly like the other one. You just need to find the equilibrium price like explicitly. The other one didn't ask for that. But we need to find the equilibrium price. And basically we have to given the demand equation, given the supply equation, we need to find the P bars such that the prices are equal when the quantity is equal. So I have Q is equal to 15 minus 1/3 P, and then Q is equal to P minus 5/3. I can set these equal to each other, so 15 minus 1/3 P is equal to P minus 5/3. Um, I solved this, so I'll just multiply the 3 over. I get 45 minus P is equal to P minus 5. And then I subtract I add the 5 over. So, I mean, I add the 5 over and then add this 5 over and then add this P over. So I get 50 is equal to 2P, so I get P bar is equal to 25. So this is the equilibrium price. Now using the equilibrium price, I'm gonna find the equilibrium quantity. So I use this formula. So Q is equal to 25 minus 5/3, which is Q is equal to 20/3. So that's the equilibrium quantity. Um, so for A, this is the answer. Now I need to find consumer surplus and producer surplus. Consumer surplus is basically just integral for P bar. Oh no, it is dq minus P bar dq from 0 to Q bar. And then producer surplus is 0 to Q bar, P bar minus the Q, dq. Yeah, okay. And so we can solve these separately though. I have that consumer surplus CS is equal to 0 to Q bar, which is 20/3. DQ is actually just, I have Q is equal to 15 minus 1/3 P. So I need to solve for P. I'll do Q plus Q minus 15 is equal to negative 1/3 P. This means that P is equal to I need to multiply or divide by 1/3, so I multiply by -3. So -3Q plus 45. So this is by DQ. I'll do -3Q plus 45 minus P bar, which is 25 DQ. Then I take the integral. I need to do this. -3Q plus 20. I'm just simplifying this right now. DQ. Then you take the integral from DQ squared over 2 plus 20Q. 0 to 23. Then solve. -3 times 20/3 squared over 2 plus 20/20 times 20/3. And then the other part just zeroes out, so I don't need to think about that. And basically what you get is Negative 3 times, this is 400 over 9 when you square it, plus 20, this is 400 over 3. And then, well, I have negative 3 times 400 over 9 times 1/2 plus 400 over 3. This cancels, so I have negative 3 times 200 over 9 plus 400 over 3, because these two cancel like that. They cross cancel, and then, yeah, you keep going. This cancels. I have 200 minus is 3 plus 400 over 3. So my answer is 200 over 3. This is the final answer. And if you plug it into a calculator, you get 6.6 repeating. Okay. Now let's find the PS, the producer's surplus. Producer surplus is going to be the same thing or similar. It's just like you set up the integral. But I have from 0 to q, which is the equilibrium quantity, 25 minus surplus equation. I need to once again put it with respect to q. So let's just solve that really quickly. I have that q is equal to p minus 5 over 3. And then, so then I have 3q is equal to p minus 5. Then p is equal to 3q plus 5. So that's what I get. So 3q plus 5 dq, something like that. And then you can simplify a little bit. 25 minus 3q minus 5 dq. Then you get 23. 20 minus 3q dq. You take another, you do it again. So 20q minus 32q squared from 23. And then you get 3 minus 3 over 2, 20 over 3 squared. This is 400 over 3 minus, this is 3 over 2 times 400 over 9. So it's really similar numbers. I have 400 over 3. This actually cross cancels, so I get 3 and 1. This cross cancels as well, so I get 200. And then you have the same answer. So this is also 66.6 repeating. Okay. The consumer surplus plus the producer surplus. So we got 200 over 3 for both. So you can just add it and you get 400 over 3, which is probably around 66. It's around 133.3 repeating. Okay, so this is the first problem. Okay, so this is the next problem. This is problem number 3. We're trying to find the continuous money flow of R of t is equal to 60 minus 5t over $2,000 per year until R of t, which is this, becomes 0. Find the total value. So we need to find the total value, which is just the integral from 0 to some time of R of t dt. So let's find this time first. So we know that this time occurs when R of t is equal to 0. So let's set 60 minus 5t over 2 is equal to 0. This is R of t. And now we'll solve. So I'm going to add the 5t over 2 over. Then I get 2, I'm going to multiply both sides by 2, so 2 times 60 is equal to 5t. Then I get 120 is equal to 5t. Then I get t is equal to 24. So I get t is equal to 24, and actually this will just be my big T. So from 0 to t, which is 24, I need to evaluate 60 minus 5t over 2 dt. This should be a simple integral. I get 60t minus 5 over 4t squared from 0 to 24. This is just 2 times 2, by the way. 60, 24 minus 5, 2 times 2, 24 squared. So you basically get 60 times 24, which is, I don't know, 24. Oh, this is 120 times 12. So 144. 1,440. Minus, this is 24. 5, 4, 24. So actually I get 6 times 24. And you can punch this into a calculator. But I am not going to. But I'll do this one in the calculator. This is minus 720. So 144 minus 20 equal to 720. And so this should be the answer. Let me just double check. Yeah, this is $720,000. So this is the first one. And then now let's find the present value. So we know the equation for present value is equal to the integral from from a to b of r of t times e to the a minus t times r dt. So this is the formula. We'll use this information though. So I know it's 0 to 20. Then I get 60 minus 5t over 2 times e to the negative 1 over 24t dt. So this is the integral you're trying to evaluate. This one is an integration by parts, so I'll show you. Let u is equal to 60 minus 5t over 2. Then let dv is equal to e to the negative 1 over 24t. Then du is going to be equal to negative 5 over 2 du. V is just going to be equal to negative 24 e to the 1 over 24t. This is because you basically let u 1 over 24d. And then du is equal to negative 1 over 24. And then you have to solve for negative 24 du is equal to dt. Something like this. So that's the reason why. But now we need to do the bound. So 60 minus 5t over 2, negative 24e, negative 1 over 24t, minus dv du, so negative 24 e to the negative 1 over 24t times negative 5 over 2 dt, evaluated from 0 to 20. This is also evaluated from 0 to 20. But we will disregard that for now. Then rewriting this, I get this minus, well, I have a negative negative, so I'll turn that into positive. Then I can kind of take out this 24 as well, just evaluate this integral. Well, actually, I could take out this whole constant. So actually, I have three negatives here, so I'm gonna turn that into negative, and then I'm gonna multiply this by 5 over 2. So yeah, I have three negatives here. And then this turns into the integral from 0 to 20 of e to the negative 1 over 24t dt. And then if we look earlier, we did evaluate this already, so I'm just going to plug it in. So this is actually just equal to negative 24e to the negative 124t from 0 to 20. Okay, so we will just evaluate this now. Okay. I added the bounds here. It's just more symbolic, but you just have to keep in mind that you still need to evaluate it with the bounds. There's no really easy way to do this other than just plug in, but I know that, yeah, there's no really easy way to do this. So 60 minus 5 times 20 over 2 times negative 24 e to the 1 over 24 times 20 minus 24 times 5 over 2 times negative 24 e to the 1 over 24 times 20. Okay, so this is the first part. Second part might get easier just because there's zeros in it, but this is going to be all of this minus 60 minus, well, I'm just not going to write the zero term. So if I plug into 0 into negative 5t, I'll get 0. So minus 0 times negative 24 e to the 1 over 24 times 0. So this is just to the power of 0 minus 24 times 5 over 2 all times negative 24 e to the power of 0 once again. And so this is the next part. Yeah, so this should all be just like plugging in terms. So I'll leave that to you, but this should be correct. Okay, this is the next one. Okay, this is the next problem. We're calculating the future value. So we wanna build the integral so it's from 0 or from a to b of rt times e to the r of b minus t dt. So in this case, our integral is 0 to 15 of 80,000 times e to the 0.04t e to the 0.05 times 15 minus t dt, which is from 0 to 15, 80,000 e to the, well, this 0.05 times 15 is just 0.75. And then 0.05t minus. So I'm going to combine the minus 0.05t with the plus 0.04t, so I get net 0.01t times e to the 0.75 dt. Okay, and what to notice here, I have a constant 80,000, but I also have this e to the 0.75 constant, so I'll just put this all to the front. And then we're just evaluating this integral now. Basically, this integral, through some u substitution, it just becomes, this is supposed to be negative. It just becomes negative 1.01 e to the negative 0.01 from 0 to 15, something like that. And then okay. And then we want to compute this integral. So it's negative 1.01 e to the negative 0.01 times 15 is negative 0.01 times 15 is equal to negative 0.15 minus 0 e to the 0, which is just 1 minus negative e to the 0. So this becomes 1. So I actually just get 80,000 e to the 0.75. Well, it's a 101. I'm going to bring this in front since it's positive, and then this to the back. So it's minus 0.01 e to the negative 0.15. So once you do these calculations, you should get 80,000 times e to the power of 0.75. So this is 169360, something like that. And then this is just I get around this number. 0.49. Okay. So this is the answer for number 5.